So, how do we know the number of protons, electrons, and neutrons? Well, let's take a look at the following slide. Again, the charges are all found either in the nucleus or outside of the nucleus on the electron cloud. That is, that the protons with their positive charge and the neutrons with no charge and the electrons with their negative charge are located either in the nucleus or on the electron cloud on the outer ring. So again, you can see in the diagram the nucleus, which is bracketed off, that has the neutrons and the protons. On the outside of the nucleus in the electron rings or energy levels, or referred to sometimes as shells or orbitals, you see the electrons going around with a negative charge. The symbol in the chart shows the positive sign for the proton, none for neutron as it has no charge, and a negative sign for the electron. So, where is most of an atom's mass located? I think you can conclude that it is located in the nucleus, as most of the mass between the protons and neutrons is located there. You can see that a proton has one atomic mass unit. The AMU is the unit that we use to indicate the number of protons as well as the number of neutrons. Electrons are much smaller in mass, and therefore they have a smaller number, a smaller atomic mass unit. How can I determine the number of protons, neutrons, and electrons an atom has? Well, let's take a look by using the periodic table. So let's look at sodium, for example. You can see in sodium the name of the element is located at the top of the box that you would find on the periodic table. Then you will see the number, which is what we refer to as the atomic number. The atomic number tells us the number of protons, which is, remember, in the nucleus, as well as the number of electrons, which are located outside of the nucleus. Then we have the element symbol, or the atomic symbol. So sodium's symbol is Na. At the bottom, you notice the atomic mass. The mass is the number of protons plus the number of neutrons added together. In order to determine the number of neutrons, which is also in the nucleus, we will take the mass number, the atomic mass number, minus the atomic number. So let's look at this model. The Bohr model is one way to represent how the atom would look if it were stationary. Again, this is a model. It's not showing an accurate representation of how it would look, but it is a way for us to understand how things are located in their structure. So, the rules of this Bohr model are, as you can see, the blue shaded circle in the center, that would represent the nucleus. And then you see three rings or circles coming out from the center after the nucleus. The first level, the rule is that it can hold 2 electrons. The second level has the ability to hold 8 electrons. And the third level can hold 8 as well. What this means is, in order to fill one level at a time, we fill the first one with 2. If an atom has more than 2 electrons, then it requires another energy level, and the maximum that can be held there are 8 electrons. And then if it requires more than a total of 10 electrons, then we add another ring, which can hold up to 8 electrons. Okay guys, so now that we have looked at the rules of the Bohr model, let's take a look at sodium specifically. And I'm going to adjust my little monitor here for you. You can see that this is the STAR reference document, and this is what you'll be using on the STAR test, 8th grade science STAR test coming up at the end of the year. And here we have sodium. Okay, and if you look closely, you'll notice that, let me zoom in, you'll look closely, you'll notice that atomic number for sodium, which is our number at the top of the sodium, which is right here, number 11, and I still can't see it, so let's adjust. Let's adjust this. Okay, there you go. Now you can see that sodium has an atomic number of 11. And remember, the atomic number is the number of protons. And if we know the number of protons, we also know the number of electrons. You'll also notice that it has the symbol, which is Na for sodium. And then right below that is our number, which is 22.9. It's a little fuzzy, but the atomic mass is the 22.9. Now, if you recall that in order to get the neutron number, we have to take the atomic mass, which is this number right here, and we have to subtract the atomic number from that. And Mr. Burrs taught me a little trick that he uses in his classroom that he calls the MAN method. And if you will look, MAN is for the atomic mass. The mass minus the atomic number is equal to the neutron number. So if we take the atomic mass, which is 22.9, and we want to round up because anything 5 or higher, you know, we're going to round up, so that gives us 23. And if we subtract the atomic number, which is 11, you like my scratch work? 23 minus 11, then we know that that gives us 12, and those would be 12 neutrons. So the M is for the mass, the A is for the atomic number, so it's the atomic mass minus the atomic number, which is equal to the N, which is the neutron number. So this for sodium is 12 neutrons. Now if you look at the Bohr model, let me flip it out here for you. The Bohr model for sodium, we just established that the proton number was 11, which is our atomic number for sodium. So this is sodium, you can see here. And that is also found in the nucleus. Remember, the protons are found in the nucleus. We know that if we know the number of protons, we also automatically know the number of electrons, which is also 11. And remember, the electrons are found in the outer rings, which we're going to look at in a moment. And we did our trick that Mr. Burris taught us, the MAN trick. And we know that it is the mass, which was 22.9, which we round up to 23, and we subtract the atomic number, which is 11, and that gave us the 12 neutrons. So we're going to take that and fill that in up here. Now let's remember that when we look at the Bohr model, we had 12 neutrons and 11 protons. Now remember, the electron number is also always the same as the proton number, and this is what we call the nucleus, this little ring here in the center, this circle. And then from there you can notice that there are 3 rings coming out from the nucleus. Now we have 11 protons. We need to put our electrons on our energy levels to represent our 11 electrons that exist. Now remember, based on the rule that we went through earlier, there are only allowed to be 2 electrons in the first energy level, and since we have to get to 11, we can't go any further than 2, so you'll notice that we have 2 here. And 11 minus 2 we know is 9. And we know that the second energy level can hold up to 8. So we have 1, 2, and we're going to just draw those in here. You can see that I'm drawing those in. 3, 4, 5, 6, 7, and 8, because that's the maximum number of electrons that can be held in the second energy level. Remember, we refer to those also as rings, sometimes shells, and sometimes orbitals as well. Now, so far we have 8 plus 2, which makes 10 electrons. We know that the atomic number is the number of protons, and that tells us the number of electrons. And those electrons are what are orbiting on the outside of the nucleus, and that is 11. So we need the third energy level, and we need 1 more electron to be there. Now remember that this outermost ring is what we refer to as our valence level, and that is our valence electron. So in this particular example, for sodium specifically, the atom of sodium, we are given 1 valence electron. So let's look down here at the bottom. So sodium, remember, has 11 electrons in its outer shell. Well, actually no. Therefore, it also has, well, it shouldn't say, it should say 1. So we have a total of 11, but in its outer shell, we have 1 electron. And anytime we are looking at the outer shell, we know that that is the valence shell, and it is always the same. So therefore, they have 1 valence electron. Now remember, they have a total of 11 electrons, but in the outermost shell, we only have this 1 little valence electron, which is this one right here. Okay, so that's looking at sodium and its Bohr model and its energy levels. Let's take a look at one more. Let's look at oxygen. Okay, so oxygen on the periodic table, let me show you on our periodic table so we can look here. Remember that this is what you're going to use on the fun little star test that we have coming up. And on this, you'll notice that it has a lot of information, so that's going to be really good to use when you get to that star test. It has the atomic number here for you, has the symbol, the atomic mass, and of course the name of the element. It shows you all the periods and groups and families and rows and everything you need to know on the periodic table. Now let's find oxygen. Oxygen is over here. It is number 8 on the periodic table. You can see oxygen here. Let me zoom in for you. This is oxygen. I'm learning how to use this better. So oxygen has an atomic number of 8. Let's see if I can scroll in there for you. Okay. Oxygen, there we go. So oxygen is here, and oxygen's atomic number again is 8. There's the symbol, which is O for oxygen. Its atomic mass is 15.9, and of course the name of the element is there. Alright, so let's take a look at our Bohr model for oxygen. We know that our Bohr model shows oxygen's periodic number is 8, or its atomic number is 8. Okay? Anytime we know the number of protons, we automatically know the number of electrons. Okay? So I'm going to go ahead and fill my protons in here in the center of my nucleus of my atom, which is 8. My neutron number I'm not sure on yet, but we're going to figure that out in just a minute. And we know that our atomic mass is 15.9, and that always is going to round up to 16. Okay? And remember Mr. Burris' trick, the man trick? Okay, so he has the man, which is the atomic mass minus the atomic number, so we have 15.9, which we're going to round up to 16, so we're going to just round it up, minus the atomic mass. Remember, the atomic mass is 16 minus the atomic number, which is 8, is equal to the neutron number, which is 16 minus 8, which is 8. So we have 8 neutrons, so we can fill that in. Now, as we saw in sodium, the proton and neutron number was not the same, but in this particular example, it is. Okay, let's fill in our energy levels for oxygen. We know that this is the nucleus here in the center. Okay, then this is the first energy level, and recall that only 2 electrons are allowed in that first energy level. So there's the first 2. We need 6 more electrons to be filled in. We can't go more than 2 in the first energy level, so we're going to go out to the second energy level, and we know that we need a total of 8. We've already got 2, so we need to fill in 6 more. So 1, 2, 3, 4, 5, and 6. Okay, now we could add 2 more, but our atomic number is 8, and so therefore we are done. Now, we do not need this third energy level, so if we were going to draw this by ourselves, we would not draw that third level. We don't need it because we only need this second energy level. So therefore, this outermost ring, the second ring, becomes our valence shell. Okay, so our valence shell. Remember that our valence shell represents the electrons in the outermost ring, and that's our outermost ring, and so we have 6 electrons in the outermost ring. Anytime we have electrons in the outer ring, that also means it's our valence electron number, so therefore we have both. Okay, so this should summarize to you pretty clearly on the structure of the atom. Remember that on your Wix document there is an action item, so please be sure that you see that. and you're basically going to be copying and doing similar what I have just done here with sodium and oxygen for another element off the periodic table. So be sure to add that to your Wix document. Alright guys, thanks, see you later.